In this paper, we propose an effective data-driven method for high-resolution mesh deformation. With our method, users can easily create a detailed mesh deformation sequence from sparse training examples. Here, we show a deformation sequence generated with our method. The input to our system includes a sparse set of aligned high-resolution meshes at different poses and sparse control points defined on the mesh. We use them to train two data-driven deformation models. The first local CCA-based skinning model correlates large-scale smooth deformations with control point movements. The second displacement model correlates control point movements with high-resolution deformable details. Given novel control point movements, these two models deform the large-scale mesh and its details separately to generate the final result. Please see our paper for details. Here we compare deformation results generated with the static displacement map and with our pose-dependent displacement prediction model. Note that our displacement model well predicts detailed mesh deformations and generates convincing results. On the contrary, the static displacement map cannot reproduce the detailed mesh deformations. Here we compare results generated by our local CCA-based model against results generated by the global CCA-based model in Fang 08. Our local CCA-based skinning model well predicts new deformations from sparse training poses, while the global CCA-based model extracts false dependencies from the training data and gives rise to artifacts in the deformation results. Now we show some mesh deformation sequences generated by our method. First, we show an animated hand generated from 14 examples scanned from a real hand. The control point movements are specified by the user. Note that the detailed wrinkles in the palm deform consistently with large-scale deformations of the whole hand and generate convincing hand motions. Here, we show rendering results of another hand model with different gestures. Despite the sparse examples used in our method, our system generates natural finger movements and plausible wrinkle deformations for different hand motions. Our method can also generate mesh animations from motion capture data. Here, we show an animation of hand 1 driven by motion captured control point movements. Here is an animation sequence of hand 2 driven by different motion captured data. Despite the noise and control point movements, our results still exhibit a smooth mesh animation with fine scale details.